Welcome to Lakshmi Academy. Today's topic is database testing, and I will go over some of the topics in detail so I can cover all the questions which can be asked during the interview process, and it can help you when you're working. Let's go over some of the basics of database before we move into database testing. What is a database? Database is an organized collection of data which provides efficient retrieval of the data. What is the data? Data is a collection of information, statistics, which is stored for analysis and reference. What is DBMS? DBMS stands for Database Management System. It is a system of systematic way of creating, storing, retrieving and managing of data. Examples of DBMS can be file system, XML. What is RDBMS? RDBMS stands for Relational Database Management System. It is a database system based on relational model. Examples of RDBMS can be SQL Server, Oracle. What is database testing? Database testing is a process of testing the behavior of the database with reference to front-end application. So front-end application can be web application, desktop application or mobile application, any kind of app. So in the simple words, you can put it as any changes made in the front end of the application should change the back end, and any changes made in the back end should reflect the front end of the application. Now, database testing involves data integrity, data validity, testing the database performance and testing of functions, procedures and triggers. Testing of functions, procedures and triggers, in most of the time it is unit tested by developers, but in some cases a software tester can also test functions, procedures and triggers, and we will go over in details about all this involvement in database testing. What do we need to check in database testing, or what normally you would check in database testing? You do constraint check, verification of field size and type, testing stored procedures and triggers, and performance based issues. How do you test data integrity, or what do you take into consideration while verifying data integrity? And it is always a good practice to support your answer with an example. So data integrity, you verify any of the create, retrieve, update and delete operation, which is also called as CRUD, C-R-U-D. It should display most recent values and status of the shared data on all the forms and screens. So data consistency is maintained throughout the application, and I can explain you with examples so you understand it better. Take example, in this tutorial I will try to take a banking application example, since all of us have a bank account and we know how it works. So there is a banking application and the customer is depositing the money. So once the deposit is made, the balance will show the change. So there may be more than one screen with account summary, the second screen with the checking account balance. So the change in the balance should be shown on all the related screen. So there is a data consistency maintained throughout the application. So you should design test cases in such a way that when you do any of these operations, create, retrieve, update and delete, create, update and delete operation, then it should the change should show on all the related screens. Verify blank value can be retrieved from the database, and you can use simple SQL statements to test this. Verify each value is successfully saved to the database, and truncation of strings and rounding of numerals occurs as per business requirements. So you need to verify that whatever you are entering in the application is saved successfully, and some business requirement may need truncation or rounding of numerals, but very few chances you need to check the business requirement. But If the business requirement doesn't say truncation of strings, then you need to check whether it's truncating the string, because the user interface may take 15 characters and database may store 10 characters, so you're losing the information. Rounding of numerals is very important. If it does not mention anything in the business requirement, then you should check that rounding of numerals does not happen, because rounding of numerals in financial application like banking application, mortgage application, it can make a huge difference. So rounding of numerals, thorough testing needs to be done. Verification of data compatibility against older version of hardware and operating system, because there may be users who are using older versions of operating system and hardware. Verifying the data updated, modified or deleted from the front end or reflected in the back end. And many times for software testers who are in the freshers, they have a question: do we really need to access the database to do database testing? The answer is no. It depends on the company and it depends on your job. Database testing can also be done with the user interface, and many times it's better to do by accessing the database, but it can be also done by user interface. Like suppose you are creating a user account, so you enter all the information using the user interface, and then you save the information, and then you go to edit screen, and then you go to the edit screen and see if all the information is saved, whatever you have entered. So there are ways you can do database testing without accessing the data directly, but at higher level you need to access the data and you need to know SQL queries and the basic commands in SQL. Let's move on to the second question. How do you test data validity? So you test at a field level validation, form level validation, data saving validation, search criteria validation. How can you reduce data corruption which occurs by human errors? This question may be asked if you are a very experienced testers, because this is more like a developer question, but it can be asked during the software testing interview. So data corruption, what do you test or how can you reduce? You can do range validation, lookup validation and masking the input validation. Range validation, suppose there is a requirement to enter the age, so the age can be positive, so the range is positive. So there can be a validation in the field at the field level that the user cannot enter negative numbers. If they enter negative numbers, then a error message or a warning message shows up. Error message would be more apt according to your application. Lookup validation, especially for if you're entering the date, like there can be the user can make mistakes like entering the date, day and month, whatever the format you have set up for your application. So many times you will see the pop-up calendar which will, from where you can select the date. So in this way you reduce the data corruption by human. Masking the input in the front end, or it can be done at the in the database, and masking the input for phone numbers, social security numbers, barcode, all those fields they can mask the input. How will you plan data performance testing? Set and define performance goals regarding load and response time. Define resources and build virtual machines to identify database behavior with different machine configurations. So when you build virtual machines, you have a wide scope to test different configurations. Create multiple users to verify the response time for executing the transactions. So you can see how the multiple users can handle the database can handle the multiple users when you create multiple virtual users. Time taken by database to fetch specific records or number of records should be verified. When your performance testing, include editable transactions and non-editable transactions. Editable transactions can be write only or read write. Non-editable are only read transactions. The example can be like a customer is making a deposit or a withdraw, or the money is withdrawing or depositing, then it's an editable transaction because he is updating the data. Non-editable transaction, making a balance inquiry. that's a non-editable, that's only read-only transaction. So you have to include all these test cases in your so you can cover editable and non-editable transaction. Design test cases to identify the system breakpoint. What will you consider while testing stored procedures? You have to relate the stored procedure to the business requirement. Find out what exactly stored procedure is doing, how it is related to the business requirement, a number of rows affected, extracted records, what it is supposed to do and what it is not supposed to do. So you can do positive and negative testing here. And you can write down queries to see if stored procedure is extracting the right data. If there are any parameters included, then check parameters. Call stored procedure with valid data, invalid data, and boundary data. If at all it's returning any values, and then whenever failure or success occurs, validate the return value. Make stored procedure fail and check for error messages, whether it gives error messages or it just blocks the system, its behavior also. You should try and fail the stored procedure. Find out exceptions where stored procedures can fail. So you need to find out exceptions based on your business requirement and use your software testing logic where it can fail. Name and explain database testing validations. Let's go over first data mapping. In the software application, data often travels back and forth from the backend database to the user interface and from the user interface to the database. To validate whether the fields in the user interface are mapped consistently with the corresponding database table, and also you need to map it with the fields within the table. And I have an example here, and since we are talking about banking application, let's continue with that. We have a form here. It's a customer name, account number, customer address. So customer name, it will map to the table, customer table, and it will map to this field, name field. Account number will map to a account table and it will map to account number field. Customer address will again map to the customer table. So this one form will have different fields which are mapping to different tables. So you can enter the information in the front end and check whether it's saving in the right table, in the right field. And also you can make changes in the database and check in the front end. Whenever certain action is performed in the front end of an application, a corresponding create, retrieve, update and delete actions gets invoked at the back end. So you need to verify this. Asset properties validations are also equally important. Asset, A stands for atomicity, C for consistency, I for isolation, and D for durability. Now let us see in details. Atomicity means that a transaction either fails or passes. If a transaction has multiple steps and any part of the transaction fails, means entire transaction has failed. So it is either failed or passed, positive or negative. There is nothing in between. Suppose a customer is doing a transfer from his saving account to his checking account, and then it goes through the first step of entering the information, entering the amount and everything, and then a second screen, there is no enough balance or the customer loses the connection or anything happens, the transaction fails. So it is failed. It is not like halfway in between. There is nothing halfway in between. It is either failed or passed, and that is atomicity. Consistency. A transaction either creates a new valid state of data or rolls back to the original state if any failure occurs. So we can take the same previous example. A customer is doing the transaction of transferring the money and it fails in between. So when it fails, it is rolling back to the original state. And if it is passed, then it will create a new valid state of data. So new data will be updated. That is consistency. Isolation. A transaction in process and not committed should remain isolated from other transaction. So in a database, there can be multiple transactions occurring simultaneously. So one transaction, until it is committed or complete, it should remain isolated from other transaction. So there must be logic put in there by the developer where they should know in which order to process. And it goes into more details, and it's more like a developer where deadlock and the access and everything comes into picture. But we need to know right now, from the software tester's point of view, we should check whether a transaction remains isolated from other transactions. Durability: once a transaction is completed and committed, no external factors like power loss, technical failures like hardware crash, reboot, networking issues, anything should be able to change it. So once the transaction is complete and it's committed to the database, suppose the person goes and withdraws the money and the transaction is committed, then there is a power failure or the system reboots, but the transaction is already committed, so there won't be any change to the withdrawal he made. So the balance will show whatever after the withdrawal the balance is. And most important, business rule adherence. Your database should follow the business rule adherence. Suppose a bank application you are designing, you're testing, and bank account needs to be 11 digits. Then the database should be structured in such a way that account number size will be 11 digit. Or it can be a requirement, business rule is it should be preceded by 2 zeros, then account number should be preceded by 2 zeros. Let's move on to the next question. What SQL statements have you used in your database testing? And these are very important. When you do database testing, you need to know the simple SQL statements, the basics. DML, data manipulation language: update, insert, delete, select, merge, call. DDL, data definition language: create, alter, drop, truncate, comment, rename. Data control language: grant and revoke. Transaction control language: rollback and commit. Now, just knowing the vocabulary of these statements are not enough. You need to know the details, and I will have a separate tutorial on each statement details. But you need to know the command and how it is used and when to use it, what it does, what it does not do. So just knowing the vocabulary is not enough, because I'm sure for database testing question, if your majority of your job involves database testing, then you're sure to be asked this question about the SQL statements. How do you test database manually? So you do create, retrieve, update, delete operation in the front end, and verify data is changed accordingly in the back end. Or you can do some operations in the front end, and then like adding the customer, and then go and edit the customer and see if the information is saved. You can also do it from the front end and use front end and back end. How do you test trigger? Now, trigger should be related to business requirement. Understand the trigger, what it is supposed to do and what it is not supposed to do. You can test the trigger by querying the common audit log, where we can see triggers fired. An example I can give you is it's a banking application. Suppose there is a employee gives extra percentage of interest for a saving accounts. Then the trigger is fired, that it prints out the previous interest rate, the new interest rate, and the difference. Or example, there is a employee table, and every time the employee gets a raise, then the manager gets a printout, a trigger is fired, because and the triggers are based on the table. So the employee table, the salary gets increased, the corresponding manager gets a printout, that or an email saying that this person's previous salary, existing salary, and difference in salary. So this is how you can test the trigger, but understanding the trigger and relating it to the business requirement is very important. What is data driven testing? Data driven testing is an automation testing most of the time, which tests the output and or input values, and these values are read directly from the data files rather than using hard coded values. The data files can be CSV, Excel, text files, data pools. It depends on what kind of files you are comfortable with and what kind of files your company is using. So I have a separate tutorial on data driven testing, which goes into details and covers most of the concepts about data driven testing. This is all about database testing. I hope you find this tutorial helpful. Please subscribe Lakshmi Academy on YouTube for more videos.